Hello everyone and welcome to another episode of Astronomy Answered Simply. Today's question is, how do we know the universe is still expanding if the light we see from distant galaxies is millions of years old? Well, let me start blowing your mind. The closest galaxies are millions of years old. The most distant galaxies are billions of years old. And the reason we know this is because the further away those galaxies are, the more red-shifted the light is in the spectrum of the galaxy. So the electromagnetic spectrum is starts off with radio waves, starts off with radio waves on one end of the spectrum, and then gamma rays at the other end of the spectrum. Yes, I went to that blue screen because, well, that's what we've got. So radio waves are really long wavelength, slow, low frequency, low energy transmissions. Gamma rays are ultra high energy transmissions. Now, visible light and the light we see from distant galaxies is mostly in the infrared or red spectrum, which is the lower energy. The light from those galaxies, we can tell what it originally was and that it has slowed down and extended over time because it's losing energy as it travels, and it stretches out as, it's had to travel farther and farther. So we can measure the change from what it was supposed to be to what we're actually recording, and that's known as redshift or blue shift. You can see this it's kind of like the Doppler effect when you hear a train go by. The train gets really loud as it's coming towards you, and then as soon as the train passes you, it drops off real sharply and gets quieter and quieter until it goes away off into the distance. So that compression of the sound or light as it's coming towards you would be a blue shift, but if it's going away from you, it would be a red shift. So that red shift or blue shift in the light of the galaxies or of stars or of quasars or of pulsars, that's what we measure to determine how old something is and how the expansion of the universe is. Now, Hubble did this back in I think it was the 1920s, 1930s, and he discovered that the more distant the galaxies, the higher their redshift was. And with this, he was able to determine that the universe is expanding, and not just expanding with more accurate measurements. We've been able to determine that the expansion is accelerating and getting faster. So that's how we know. It's understanding the wavelengths of light. And there's many really good videos out there already on this, but I'm going to work on making a really good one. But I just wanted to give you kind of the overall high-level explanation. That's why I'm doing Astronomy Answered Simply. And I'm probably going to redo all of these videos at some point in the not-too-distant future to improve them and hopefully add some graphics and something, a little more fun than just me sitting here babbling at you. So anyway, it's because of the red shift and the blue shift in the light, and we can measure that as astronomers. We can measure how much something is red shifted or blue shifted based on things like there's a whole astronomy lesson in here that I'm not going to go into right now, but I'll cover that in another video. But it's the short answer is redshift versus blue shift of light. For example, the Andromeda Galaxy, which I talked about a couple of videos ago, is blue shifted towards us. It's moving towards us at I think it's like 70,000 kilometers an hour or something like that. It'll be here in about 4 billion years. It'll start merging with our galaxy. It's actually already starting to gravitationally interact with our galaxy. So in the next few 100 million years, we'll be able to see streamers from each galaxy slowly working their way towards each other, and then in a few billion years, our sky is going to be really gorgeous because the Milky Way and Andromeda are going to kind of have this really cool swirling merging pattern over billions of years, and it's going to be pretty cool. But you and I are unlikely to see that, so yeah, that's sad. But basically, red shift, blue shift of light. That's it. That's how we can tell. And we'll cover more of that in the physics lecture. Have a great day. Bye.